Do 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 do. Um. Okay. I think we are. I. Okay. So if we don't remember what we were doing last time, essentially we wrote this delete. And what we need to do is do something similar for upsert. Okay, so okay, nice. All right, so I think what we need is like an a maybe lm function. But what I want to do is there already something like this? Um, and what is it called? Because we might be able to just use it. First class families. Haskell. Need to do something with length find. Stingfinity. What's going on? I don't know what that name means, but I like it. It's gonna be a pretty quiet chat right now because I just started. But you know, hey, how's it going? So this is what I need. Good. I'm doing well. I'm doing well. Just trying to figure out this code, and hopefully we will. I have no idea. It's pretty hard. It's pretty difficult, but I think this is what we're looking for. We need this function here, but maybe we really need find index. So Haskell, huh? Dang, why? Um, it's mostly because I'm very interested in theory. So there's a lot of theory to be done with Haskell. So I'm kind of just using it as an angle into more theory, but I do want to do more practical things with it at some point. We'll see when that happens. I'm not really sure yet. I think we need a find index. That's what we need. Um, but yeah, I mean, Haskell's really fun. I think it's a cool language. It's pretty concise for what you get to write, like the power of what you get to write. So, wait, why do I need? Don't I just need this? Well, I need something to apply this to. So, Oh, sure. I'm not really I don't do professional programming. I run a supercomputer actually. So, but I'll try and do my best. Like a lot of the financial industries are using Haskell because like it's really really important that your code or like the programs that you write are correct. So there's usually like some theorem proving software like Agda attached to like practical Haskell code. So that happens quite often. But I would say that generally speaking, the use of Haskell in industry is pretty low. Um, Generally speaking, I don't know what to call this yet, so I'm gonna put empty name here for a second. Yeah, I mean it really is more of a hobby for me, personally, than anything. I'm not using it for anything practical yet, but there are plans to do some practical things on the channel at some point. But right now we're sort of diving into theory, like so like what I'm doing right now, if it's not clear, is I have this thinking with type book, and I'm basically just working through the book and implementing the pieces that we come across. I write in other languages, so I have a decent amount of experience with Python. I've done some Fortran and C++ for grad school. I've never written Java. I've written a little JavaScript, but I kind of do some programming here and there. But I don't know. I find programming languages fascinating, so that's kind of, there's a lot of development going on in Haskell for language, so it's kind of just interesting more than anything. I'm not going to be able to justify it that well. I mean, it's just kind of something I want to do more than anything. So that's really all. Freeman, thank you for hosting with Four Chatters. I really appreciate that. I wasn't quite sure what you were working on, but I did watch you for a very very short period of time there. Right before the stream. I'm usually checking you out between like 7 and 7:30 my time. Fortran is what our financial industry used before Java. If you write that well, move to the Netherlands and prepare to be rich. Yeah, that's what I want to do. No, I found writing Fortran really frustrating, but it was mostly because the Fortran that I experienced was not very good. I need to create this. How do I create that? I think we already have something. Find Elm. Fortran 4000? What's 4000? Not sure I know what 4000 means in that. Fortran. Oh, right. This is what I want. Basically. Because I need to wait. No, it's not what I want. That's okay. Fortran had generations. I don't remember. So like the Fortran I'm familiar with is 77, 90, and like the most recent one that I know of is 08. So those are like the three standards that I recognize. I don't recognize Fortran 4000. That doesn't mean it doesn't exist. I don't recognize the name. So this is gonna be like, it's gonna be like that filter. I need basically this. And then we need the list, which is TS. And then what else do we need? And that's gonna give us a maybe. Okay, so I know that this is behind my head, so Let's format so we can read it. Or face, head, something like that. Okay. So something like this, I think. It seems to type check, so that's good. Wait. I'm looking at the wrong thing. That's okay. So we're gonna find the index where the symbol is equal to the key. And this is gonna return a maybe nat. I mean, this is really find index, but applied to our specific problem. So what should we call it? I don't know a good name. Usually we write delete elem, so maybe there should be find maybe elem, or maybe find elem. Naming things is hard. Oh, since there's a few people watching, I want to thank some folks because we got a ton of followers randomly a day ago. They probably were hoping I was going to stream and then I didn't. Haskell, Puffin Fresh, Brian McKenna on Twitter, very interesting posts. I'm not sure if this is supposed to be one word, but Rob Chuck and Vyorkin. So thanks to all those folks who followed. I'm not sure why you followed, but I appreciate it anyway. Okay, so this gets us either a nothing, which just means it's not found, which means we need to insert it, or a natural value, or a natural number inside of a just constructor. So that's what we need to do. So I think we can just uncomment this and work with this. Okay. So the problem is now this no nat thing doesn't work. Because it's really a maybe value. So this is probably where it says use class instances to lower this kind to the term level. I should probably also check that what I'm doing is correct so that I'm not going down the wrong lane right away, because that could happen. But I want to be careful not to see the whole thing. Yeah, I'm already going down the wrong road. Sort of. I have this piece correct. Right? And then what it does is placeholder 1 of 3. What the hell does that mean? Well, I think that this solution is a little beyond our skill level. So I'm probably just going to look at it, because I don't think that I could do this without it. Unfortunately. It already looks like something I don't understand. So we're gonna try it. We're gonna try writing this, so. Most of what we've done thus far at the type level anyway is try and figure out his code, so I don't feel bad about that. So we get a key, we got a T, we got a TS, that's correct. And then we have this find index, which I did have correct, but we need to do some more stuff. So we're going to map placeholder 1 of 3 set index. So I think set index is like it's in here. So it takes a natural number, an A, and a list of A, and gives us back a list. So basically, I should mention that this type here is essentially there to compute the resulting type of our operation. So, and he mentions in the solution that this itself is a hack, and this is the class that is providing the hack. I don't know. I'm a little thrown off right now already. This seems to be a common problem here. From maybe. All right, this makes sense actually. I think I'm okay with this. So let me write this as like quote unquote normal Haskell code. Hang on, something's wrong. Oh, no. So this is essentially like okay. So if map I don't understand this 1 of 3 thing, so I'm not sure how to explain this yet. But I mean, I kind of know what's going on. So if you get nothing, essentially what that means is that the element doesn't exist. So if the element doesn't exist, then you can just insert it, and it's no big deal. So we just stick it in the front of the list. That's what this is saying. Although I'm a little confused at why we're not using something like not insert or something. Can we do that? Maybe we'll deal with that later. I'm not 100% sure. But I mean, this is really building the kind. This is building the new kind. So not a big deal. This bit I don't fully understand, but I think what it's doing is saying, wait, where's the other parenthesis here? I'm missing a parenthesis. That's why it's... Yeah, that makes more sense. It should fail there. Okay. Anyway, this is saying, like, map this function over TS. So it's basically, wait, no. It's mapping this function over the result of this function. And the result of this function is either nothing or whatever the key value pair is that comes out of here. So if we find key, this will be just something, and then we're going to map over that the setIndex function. But why setIndex? This is hard. I'm not sure. Let's keep going. Placeholder 1 of 3. Placeholder 1 of 3. So I think this means we're waiting for an A. I think it's making a lambda. 1 of 3. It's just a weird name. Sorry, Sandy. I wouldn't be able to write this myself. I'll be completely honest with you. I just don't think we had the tools to do this. Did we? I don't know. Probably. I don't have the mental tools to do it. I'm afraid that that's going to happen to me as soon as we need to do this in the wild. Oh, wrong way. Okay. Fix that. Okay, so we're waiting for an A, which is what for set index? The natural number. So this is giving us the natural number. Right. Okay, so let's write that. Because I think I understand what's going on now. So find index gives us maybe at. Then map a lambda over maybe at. The lambda is constructed using placeholder 1 of 3. So let's grab this. So set index is waiting for a nat. So, okay. So we need to provide the nat to set index. Oh, well, I've already wrote that multiple times. To do this, we need a type level lambda called placeholder 1 of 3. Basically, it shuffles the nat argument to the final position. Is that the right terminology? Not sure. I don't think so. To the penultimate position, so we can have a nat to exp list A. Is that descriptive enough? So find index gives us a maybe nat, so we need to fit together map set index over the maybe nat. So the problem is that nat comes first. So we need some sort of type level lambda. Maybe I should change the order of this. So basically, we need to shuffle the arguments in set index. Okay, so need to fit together map with set index over maybe nat. So we look at the data type. Basically, we need to shuffle the arguments in set index so the nat argument is the penultimate one. Placeholder 1 of 3 provides us the machinery to accomplish that. What do we think? Not 100% sure. I mean, I know what it's doing now, but I don't think I would have come up with this. Okay, so this gives us the final piece. So this actually applies the function. So this allows us to finish the map. Otherwise, it wouldn't actually do anything. And then this gives us the upsert location, which is just this function. Okay. Okay, so now we have a maybe nat, and we need to lower that. Have we done this before? Do we have a class in here? We've done this before, but I don't remember it. So find upsert elem. So I noticed a few people hopping in. How's it going? We're kind of reading very hard code right now, so I'm doing my best to understand it, and then maybe we can talk about it. Feel free to ask questions. It's pretty weird code, so I can do my best to answer them. So this is the machinery we need to get this maybe nat that comes out of, I guess, upsert loc and gets us an integer. Except I wrote this wrong. This is supposed to be integer. So we need to be able to go from the kind to the term. That's the point of this function. And then we need to overload these instances. So instance find upsert elem nothing, where upsert elem equals nothing. Right, instance find from integral nat val c and n. Okay, so Yeah, this is probably gonna look pretty strange. So this n is at the kind level. So this isn't at the term level. So first you need to do this proxy such that you can bring it in to the term. Well, it's really this plus this that bring it into the term level from the type level. And then you run this from integral to get an integer, and then you wrap it in a just. Or I'm sorry, an int. It's not an integer. So that's what this whole bit of code is doing. We've done this before, or we've talked about this before on stream, but maybe that's not clear. But this is the machinery you need to take a kind level integer a kind level natural number and convert it into an integer at the term level. Okay. And now we can actually write our upsert function, I guess. Key ts tf find this is wild. So eval upsert allen. Oh. I will try and explain this to the best of my abilities here in a second, but you're gonna have to bear with me for a second. I just need to finish typing. Ah. This is very wild code. There's no way this is formatted correctly. Okay. Yeah. So give me a second. All right. So first, type class constraint. Let's look at another one real quick. Right. So the constraint is that this thing, this thing here, needs to be a maybe nat. well, it needs to be a member of this type class. Otherwise, it can't reduce it. Then we take our key and our, what's FT here again? I forget what this FT is. I think it's what we're trying to insert. Or delete in this case. So insert or delete. So it's the thing we're trying to put in there. And then we take our open product, and then this is where we calculate the return type. So that's why we have this function up here, which I can discuss again if that helps. But that's basically what you're doing. So all this machinery is to calculate the return type, take your inputs, and then make sure that you uphold the class constraint that this has to be find upsert elem. Now down here, basically, we have our key, our value, and our open product. So what we're going to do is we're going to take the return type of upsert loc key ts. So this is going to give us a maybe nat, and then we are going to evaluate the upsert elem on that, so that we get either a literal nothing or this just with a nat value in it. Okay, then we pattern match on that and basically just do the operation as necessary. Wow. Just my head hurts. This is the kind of code that would scare people away from Haskell. It's almost scaring me away from Haskell. This is hard. I mean, it makes sense after someone shows me it. Like, I don't feel, I'm not that scared of this code once I see it, but if I had to write this code myself, which I was supposed to write myself, I don't know that I could do it. I think this is going to take lots of practice. I'm not sure this is a good name either. Is there a function like this? FBCA to FABC? Maybe that's not what we need. It's really this is what we need. Oh, I can't write it that way. Because I wonder if this is like a lifting function. A, B, C, D. A, B, no. B, C, A, D. This is called a slip. A slipper. Although I don't know that bit shift style argument rearrangement. Does this mean anything to anyone? Bit shift style? I'm not sure what bit shift style means, but we could call it slip. I mean, it looks closer to that than anything, but, you know. Whoa! Please tell me I saved that. Okay, that's scary. I think I accidentally hit Q. Is what it is. Yeah, so how do I feel about this? I don't feel great about it. I think that this is clearly very tricky, but I'm interested in it. Okay, so there's something called overloaded labels as well. So we earlier promised to revisit the syntax behind key. Working with open products doesn't yet bring us joy, mostly due to the syntactic noise behind constructing keys. Consider get key at example foo. There are 9 bytes of boilerplate syntactic overhead. Well, this doesn't seem like a lot. It weighs on potential users of our library. You'd be surprised by how often things like these cause users to reach for lighter weight alternatives. Thankfully, there's a lighter weight alternative. They're known as overloaded labels and can turn our earlier snippet into get sharp example foo. Overloaded labels are enabled by turning on overloaded labels. This extension gives us access to the sharp foo syntax, which gets desugared as from label at foo a, an asset type system to solve a is label foo constraint. All we need to do is provide an instance of is label for key. We can try and do this, but I'd like to do it in another file. So where do we use that in here? I don't think we use that in here. So it's only for users? Okay. Anyway, I don't really know what to think about this. I should probably add this in case we need it later. I'm just gonna put this at the bottom. Okay, and then this comes from overloaded labels. And we need to... Oh wait, we might be able to use our... Wait, why do I need that? I mean, maybe I need that as well. Did I already import this? Oh, I did. Okay. I don't know if we're gonna need that. We might need it later. I'm not really sure. So that's it for this chapter. So I guess we just... One second. Sometimes I don't remember which one of these shows off my IP address, so we'll avoid that. It's not my actual IP address, but it's still an IP address attached to me somehow. All right, chapter 12. Chapter 12, custom type errors. There we go. Okay, so it says open sum and open product are impressive when used correctly, but the type errors that come along with their misuse are nothing short of nightmarish. So let's try and use them, I guess. Oh, but I guess I need them. I gotta shut my door, hang on. Hodor up there as well. Hodor likes to watch over us. All right. So what we need. Why can't I type? Let me get rid of this stuff real quick. Okay, so reminder. Stack YAML. Oh, first things first, we gotta change this to 1330. And we need that. Wonderful. Okay, so reminder. Well, is that the right inject? Guess we're gonna find out. Where does identity come from? Data functor? Okay, so if we write project, although I think I spelled it out, project foo, and we try to basically cast it, we get the following. Okay, so does this mean anything? Not really. So I guess the point is we're going to try and correct this. So it says, as a user, when we do something wrong, we're barraged by meaningless errors about implementation details. As library writers, this breakdown in user experience is nothing short of a failure in our library. A type-safe library is of no value if nobody knows how to use it. Fortunately, GHC provides the ability to construct custom type errors. The module GHC typelets defines type error of kind error message to K. The semantics of type error is that if GHC is asked to solve one, it omits the given type error instead and refuses to compile. Because type error is polykinded, we can put it anywhere we'd like at the type level. The following 4 means of constructing error messages are available to us. We can use text of kind symbol to error message. Emits the symbol verbatim. Note that this is not data text. Show type prints the name of the given type. Some weird. Oh, it's a like a it's an mapend. No, it's the semi-group operator, and we can use this $$ to append vertically on top of one. Okay, whatever. We'll keep. Hopefully, we'll see some examples here shortly. So hang on. So type error is usually used as a constraint in an instance context or as a result of a type family. As an illustration, we can provide a more helpful error message when Haskell tries to solve a num instance for functions. Recall that the usual error message is not particularly useful. Okay, so this is the example that we're going to start with. Well, it looks a little different than his version, but it's pretty bad. Maybe if we use this, it will give us the same error as he has. Yeah. So if you turn flexible context on, this is the exact same error that he has. Okay, so what we're going to do is we're going to define an instance in here. So this is not what I should do. I should do I think we also need import GHC dot typelets is my guess. I'm trying to get the spacing right. Interesting. Oh, cool. Oops. I didn't know you could do this. Like, we could just, like, go out and improve error messages in Haskell? Could be interesting. This formatting looks really strange, so... Oh, that... Wait. Is there no where? You write where and then nothing else? Okay. So... It doesn't know how to format this. But I feel like... It's probably like this? Right? I'm gonna guess that that's how we do this. Although I'm very confused about this. This is interesting. Have we ever written this before? I don't think so. Alright, so in theory, no explicit implementation for. So we're like not defining any methods? I guess we can't, right? That's the whole point. I mean, that's not particularly helpful, but I'm not sure that this is actually all that helpful. Takes a bool and makes a T. Okay, that's cool. All right, let's see if we can do this with our open sum. So we need to find elem. Friendly. So we're basically emulating this, I think. Sorry. Oh, strange. Okay, so oh, that's not what I wanted to do. Sorry. So this is very weird. Attempted to call friendly project to produce a. So yeah, this is ending this. What? Why would I? Oh, I guess you're just adding like empty space there. Go type. All right. How strange. Okay, then I assume we're gonna write. Okay, so it says notice that friendly find alum is defined as a type family, right? See the difference? Type family, type. Um, rather than a type synonym as first class families usually are. This is to delay the expansion of the type errors so GHC doesn't emit the error immediately. We now attempt to find T and TS and use from maybe to emit a type error in the case we didn't find it. So if we don't find it, I see. Okay, so if from maybe gets nothing, then we emit a type error. That's interesting. So in theory, we now can just. I like that we don't need to wait. Don't I need to write like friendly project? Oh yes, I do. So project. Is rewriting project to use known nat can't I just put that up here? I see. Um, so it says instead of use member, we use no nat friendly find elem ttsf. TTS Like, can't be right. It's got to be FTTS, right? What? Oh, do I need an eval? It says no. But I feel like I do, don't I? What's the error here? Oh, it takes a natural number. I'm a little confused. This takes 3 things, yes? I'm confused. What's the error here? Oh, I guess we don't have... We don't really have a nothing case anymore, do we? Because we can't even get the nothing case. So we really no longer even need a maybe. I mean, unless we want it. We don't need it, though. So I think this is right. Well, let's leave the maybe there, because they're using maybe. Hang on. Yeah, that's fine. So foo. Okay, we need set x data kinds. Then we need foo equals inject. We also need that. And we already had foo inject identity true, open some identity bool string, yes. And then we should be able to use friendly project foo. Oh, we need this as well. So, but the open sum can contain only one of bool string. There we go. That's a little better. Nice. Okay, that's cool. I'm not sure what it's deciding the type of this to be. Pretty hard to tell from this. That's a pretty intense type. But either way, you can see the difference here. So if we try and use this friendly project function, we get, to produce an identity int, but the open sum can only contain one of bool string. So, if you cast this to bool, then it can read it. That's kind of neat. Okay, neat. So let's go get. You see that on the screen? That choppiness? What's that about? Is it tearing on your side? Or is it just on my side? It looks like I can see it in OBS, so. Can't I set options here? Can I just do it here? Guess we're gonna find out. Oh yeah, we'll fix that. Extensions. Where do those go? Does that go here? Extensions. Like this? How was it? No. On one line. Although maybe this works. Let's try it. We can just write build. Not obvious to me that those were added anywhere, but if we do this, so that didn't work. Oh. How do I don't understand. In here, how do I get those extensions? Do I, oh, maybe I do it outside of this. Maybe I do it here. I really hope that I can do it like this. No. Okay. Google. Google to the rescue. Default extensions. Perfect. I mean, sort of. So now we need vector 24G vector. Okay, there we go. So what are we doing next? What time is it? Okay. You know, my water thing hasn't triggered at all today. I don't know what that's about. Hopefully people aren't chatting and I just missed it. I'm only using it for the REPL, but generally I think I agree that I don't like the idea of default extensions. I'm just tired of turning them on every time I want to test this. It's more because I'm lazy than anything. Also, hello new maid, how are you? It's been very quiet today, but we did some really hard stuff. So I don't know if you saw the code we wrote a minute ago, but it was wild. Okay. Here, we should have an insert function. So here's our insert function. So let's see here. What error are we trying to produce? I'm confused. Oh, I see. Okay. So we're going to time to drink some water. All right, I gotta go get some water, but I agree with you. Need some more. Right back. Okay. Thank you, New Maid, for being the water timer. It's appreciated. Missed all the fun as usual. I'm not sure it was fun. Here, I'll show you. Well, actually, I can show you in here. So the last time we left, this is what we needed to write. So we needed to deal with this upsert function. So let's start here, because it's hard. So first thing you need to be able to do is compute the type of the result, right? So you're going to have an upsert elem that basically takes your key, which is the key you want to update, the value you want to put in, and the open product. Okay, so we're going to work from bottom to top because it's going to make more sense. So first thing we need to do is try and find the index of the key, right? So this is like equals key dot first in the list. So that's going to give us a maybe nat. Then what we need to do is map a function that basically takes that nat and uses set index to change its value. Okay, so that's what this is doing. Now, this placeholder 1 of 3 thing is basically flipping the order of the arguments. So because set index takes the natural number first, we need to flip it such that it takes the natural number last. So basically you have this placeholder 1 of 3, which I really don't like the name of this, but the only other name that we found in Haskell was slip. So there's a function called slip R and slip L that kind of does this. So, you know, we could probably use that name, but I don't think it's that important. I don't, this is weird to me. I don't understand it, but you know, that's just me. So anyway, this is basically just mapping over the maybe and getting us this, okay? And that's only true if you are doing the update, right? If you're just doing insert, you don't need to worry about this. You just stick the types together, right? So that's basically what this is doing. Does that kind of make sense? It's real strange. Again, this placeholder, all it's doing is flipping the order so that the natural number A comes last. That's so we can use this fmap. And then basically we need a function to tell us the natural number, like where is it, so that we can enforce that we're getting a natural number. And then we have to define our upsert elem to take the type level nothing or natural number and bring it into the term level. Okay, so you end up with this function for upsert. So for all key ts, right, our open product, t is the value we want to add, and the f is the, I don't quite remember how this f works. It's like a wrapper around the t. You'll see, like, we just call it f of t. So I forget what this f is exactly. And then we have find upsert elem, upsert loc key ts. So this goes and gets the natural number and gets us the maybe integer constraint. Or I'm sorry, maybe nat constraint. So the result of that has to be maybe nat. Then we take our key, our value, and our open product, and this piece computes the result type for TS, and then we can do our insert. So bring the natural number to the term level and try and upsert it. Or I'm sorry, that's exactly what it's doing. It's getting the natural number and then bringing it to the term level so that we can pattern match on it. Then once we pattern match on it, everything's kind of boring afterwards. So that's the function that I didn't write it. I read it from the book because I couldn't figure. I would have never figured this out myself. This I don't know how we practice this. Like that, I really don't know yet. Maybe we'll be able to practice it at some point. I don't know why I closed that and open it, but we're gonna start messing with insert now. So now what we're doing is adding custom type errors to these functions. So right now, when you call insert, it basically just makes sure that you're inserting a unique key. If you don't insert a unique key, it will produce some cryptic type error. Let's see if I can figure out how to. Let me see if I can do it real quick. Hang on. I just need to find an example, because I don't remember exactly how to do this. Hang on. So what do you think, Nume? Does that look like fun, or does it look like a nightmare? Because it's really, I don't think I would have figured it out. Okay, so we're gonna say foo equals insert key at key just true. It's over my head most of the time, so I think hopefully we'll be able to do this at some point. So I need type applications for this to work. Okay, can we print this? No, we can only really print the type, I think. Okay, so now we have foo. So the idea here is that we're going to try and I need to create an open product. Do we make it like an empty function? I think it was called nil. So the note here, I can see that this is taking an open product and creating an open product. I don't really want to do that. What I want is an open product with a key so that I can do the following. So now I could write insert key at key just one on foo. Okay. And if I type correctly, you're gonna get a weird error. Couldn't match type false with true. Not very helpful. So what we're gonna try and do is say, we're gonna create an error that basically says cannot insert element with duplicate key or something, I presume is what we're going to do. The other thing I want to do is we need to turn on GADTs and type applications so that we don't have to do this every time. Not there. The thing is like if I can comment this out later, right? I don't need to keep this in here. So type applications, type family. So that should work. Great. Okay. Okay. So insert. Where'd you go? Okay. So we got to do something with this unique key. Oh, I gotta go back here. So to make this work, you're going to create a type family called require unique key. Going to take a result is a boolean, a key is a symbol, a t, which is a k, and a ts, which is a symbol k. Okay, now we need to format this because this is terrible. So I suppose I can put that here. Oops. That there. There. Where unique key. True. Key. GTS equals require unique key false. Key TS equals type error. What is this complaining about? Type family, require unique key. Is this not indented far enough? Is this indented pretty far? Does that change anything? No. What is this complaining about? Parse error in pattern. That implies like I'm missing a set of parentheses, right? Very confused. Oh. Okay. There we go. I just had it tabbed out, or not. I didn't have it tabbed out, and it needed to be tabbed out one level. So we should put this back here probably, and our automatic formatter has stopped running, which is really not all that surprising. Add a field. Attempting to insert with key. Text with type. So uh so just for reference, this operator just inserts a new line. So we're gonna see basically 3 lines. All right, let's read this a little bit. There's a lot of typing here, so it's probably a little bit boring. So yeah, so attempting to insert with key named key and type and value. No. All right. I think that's right. So now all we need to do is change this to eval, I think, require unique key. Unique key. I don't know if I need eval here, but so that's gonna give me true or false, and then I need to give it key TTS. Yeah, look at that. Okay, let's try it. I don't think that this is very useful, but this is probably fine. So I think we should get rid of this, and also we have key in here twice, but um, generally it's pretty useful. As key. This lookup type I don't think is very useful, so let's get rid of that. Because that... Like, if it just said bool, it wouldn't be so bad. But this is not particularly helpful. Maybe we can make lookup key better. We probably can. We'll just leave that alone. Let's go, let's see what lookup. I mean, this is probably fine. This is at least better than what it was, right? Did I, oh, sorry, did I actually fix this? Let's see what it looks like real quick. Fine. Good enough for me. So yeah, so this thing appends to the right on the next line, and this thing starts over, I guess. So it looks a little funky when it's written this way, but it's fine. All right, so next thing is it says do the same thing for update and delete. Okay. So essentially we're dealing with this situation here. I guess get is the same way, yeah. Is friendly a good name here? I don't think so. um You're not wrong. It's pretty hard to do this stuff. Um it's very hard to do this stuff. Oh, hurts. Um let's just call it friendly. Yeah, I think so. I very much agree with that. That's kind of the problem with this whole series of things that I'm doing. Um, you kind of have to be here at the beginning, otherwise you don't follow. Because it's not like I'm just working on some random project where we can just work on, you know, whatever. We're actually building up knowledge as we go. Okay, so this is probably gonna look like this is probably gonna look like this, similar to this, except um, instead of having a bool, we're gonna have a maybe not. And if it's nothing, I suppose we're just gonna fail. So we're gonna have like result is and I guess we need to have a new find elem that just returns nothing. Although find index does return nothing. So let's leave this alone. Let's write type find elem prime key symbol es symbol k eval this. Okay, so friendly find lm is going to take a maybe nat. We want to tab that out twice. And then a key and a ts. And this needs to produce a constraint where friendly find lm nothing sorry, key TS equals type error and we're going to fill in the details in a second. Okay, so I think this is right. So we're basically going to take our new findLm function, compute that, and then we'll get a maybe. If we get nothing, we're going to give a type error. If we get a just, then we're just going to say, yeah, our constraint is fulfilled. Okay, so now we need to write this type error. Okay, so the key right? Something like that. So yes. Like if you try and update insert or upsert. So now where's our findLm function? Right, I'm looking at it. So now we need a new one that's not going to take this constraint anymore. It's going to compute friendly findElm eval findElm prime key ts. Key ts. Okay. So we're going to proxy find lm prime. Then we're going to actually oh, so Natville, right. So Natville can't work this way. Because well, I'll show you. Let me show you Nat. So it takes a proxy of n to an integer, but I now have a proxy maybe n. So actually, what do I need key in TS here for? I need it above? Why do I need key in TS? I'm not sure. But what do I want to actually do here? How do I get this thing at the term level? I guess it doesn't matter. I can just use find lm here, right? I think I do need. I'm not really sure what I'm doing here. I mean, this gets me that nothing, but that doesn't actually help me, does it? So I need to. Hmm. I need like a from. I don't know what I need. I need a nat val. It works on a maybe. Really don't know. Hmm. Oh, it's like the other one. I get it. I goofed. Okay. I get it. Hang on. Let me rewrite a little bit of this and it'll make some, hopefully, more sense. Okay. So if you look at this pattern, we actually saw this before. So what I'm doing doesn't work because I need to trigger the type error instead of this stuck type. So really, you don't have this. You have it's like source open some. More like this one. Nope. from maybe, type error. Okay. I want to finish this one and then be done. I'm starting to lose it pretty quickly. And I'm sort of looking at the answer because I'm a little confused at what they were looking at. It makes sense now because this is what we did last time, where you're basically replacing this stuck type with a type error. But in this case, you need an eval, which I don't understand why. You didn't need an eval in the other case for whatever reason. Okay, I think I'm gonna stop here because I'm losing it. But we'll come back to this exercise when we get back, and then we'll try and do the other two, if we can. Uh, we'll see. So, let me write the git add commit working on chapter 12. Hey Oren, sorry you made it late, but unfortunately, yeah, we are ending the stream. We did finish chapter 11. We almost finished chapter 12, but I'm a little stuck on one of these exercises. They're pretty tricky, and this code is pretty tricky, so I'm not sure that we're retaining all the information, but that's okay. We are going to talk about how the heck do we practice this stuff in the future. I do want to make like some sort of document or a quiz or something where we can practice this more often. So anyway, I'm still happy with the book. I feel like we're getting stuck a lot, and that's unfortunate. And I don't really have the mental capacity for this stuff to feel comfortable with it. So anyway, book has gotten a little more expensive. Oh wait, this is EU? Is this the wrong dollar amount? Oh no, this is US dollars. It's right there. Anyway, the suggested price is a little bit higher now, which is interesting. I don't know what that's about. So you can get this book here. I think it's interesting. I'm not sure everyone in here would agree it's interesting or have a hard time following it. It's very difficult to do this stuff. So, proceed at your own caution. If you're really interested in doing type level programming in Haskell, it's definitely the book to get. But yeah, the other thing I need to talk about is the stream subscriber goals. Do you guys like those? because I don't know how to get it right. So it doesn't show, like, either I can show all the subs that we've gotten thus far, or I can do like the monthly subs. But when I did monthly subs, for example, I know there are 5 people subbing right now, but it says 0 because we haven't got any this month. So what I really wanted to say is, like, you know, I have 5 subscribers and we want to try and get another one or something, but I can't get that goal correct. What do you guys think? Do you think I should just remove it, or just leave it 0 of 5 for like every month, and then when the folks resubscribe, it will just say, you know, 5 for those folks? I really don't know what to do. We can also just do it. I've dropped some frames there, interestingly enough. I don't really know what to do about it. I'll keep thinking about it, but you can see the numbers really strange today. The followers just works, but the subscribers does not work as expected, unfortunately. Maybe if I don't use a goal. Anyway, I'm talking randomly. Nobody said anything, so I don't think we're that concerned about it. So anyway, new made, Counorin, and other viewer who I don't know who you are offhand. It might still be Stingfinity, and if it is, thanks for hanging out, even though I don't think you're super interested in this. Yeah, see y'all later.